Welcome to a 2x2 example of variation of parameters. So recall, if we have the system y prime is equal to a of t times y plus f of t. And we have y1 through yn, a fundamental set of solutions. To the homogeneous y prime equals a of ty. Then we can take our solution y is capital Y of t times u of t being a vector, where y is the fundamental matrix. With first column y1 through last column yn, and u satisfies capital Y of t times u prime of t is equal to f of t. So in order to solve a non-homogeneous system, we first need to know our fundamental set of solutions for the homogeneous solution system, and then we can solve from there. So let's consider the system y prime equals 2x2 matrix, 1, 2 for the first row and 4, 3 for our second row, times y plus the vector 2 times e to the 3t for the first position and 5 for the second position. So the first thing we need to do is solve for the homogeneous system. So we need to find a fundamental set of solutions. To the system y prime is equal to 1, 2, 4, 3 times y. So to do this, first thing we need to do is find the eigenvalues. And we have 1 minus lambda, 2, 4, and then 3 minus lambda. The determinant of that should be equal to 0. So we are looking at 1 minus lambda times 3 minus lambda minus 8 is equal to 0. This is lambda squared, and minus 3 lambda minus lambda is minus 4 lambda. Then we have plus 3 and minus 8 from minus 5. So we have lambda squared minus 4 lambda minus 5 is equal to 0. This factors as lambda minus 5 times lambda plus 1 equals 0. So we can take our lambda 1 to be 5, lambda 2 to be negative 1. Note, it does not matter which one we label as 1 and which one we label as 2. Our next step is to go ahead and find the eigenvectors. And I need to update my screen. So for finding our eigenvectors, let's go ahead and first work with lambda 1 equaling 5. So we are looking at the system 1 minus 5, and then 2, and 4, and then 3 minus 5, multiplying psi is equal to 0. So this is the augmented matrix, negative 4, 2, augmentation 0 for our first row, 4, negative 2, augmentation 0 for our second row. This is definitely It gives us a free variable. We have, if we do row 1 divided by 2, we get -2, 1, and 0 for our first row. And if we just then do row 1 plus row 2, they cancel out and we have 0, 0, 0 for our second row. So we have 2 times xi1 should be equal to 2 times xi1 should be equal to xi2. So we can go ahead and pick our xi1 to equal 1. That means that xi2 should equal 2. And so we get that our vector xi1 corresponding to lambda 1 is the vector 1, 2. Now let's do this again for lambda 2 equaling -1. So we are looking at, we have 1 minus -1, and then 2 for our first row. Second row is 4 and 3 minus -1. This times xi should be equal to 0. This matrix simplifies to 2, 2, and then augmentation 0 for the first row. For 4, augmentation 0 for the second row. If we just do row 1 divided by 2, we're looking at 1, 1, 0 for the first row. We do -2 times row 1 plus row 2. We wind up with 0, 0, 0 for our second row. This tells us that xi1 plus xi2 is equal to 0. We can go ahead and pick xi1 to be 1. That means that xi2 would have to be -1. Putting these together, we get our second eigenvector is 1, -1. So we have our fundamental set of solutions. We pick y1 to be 1, 2 times e to the 5t. And our y2 is 1, -1 times e to the -t. Next up, we solve the non-homogeneous system. So what we are going to do is we are going to start off by assuming that y is equal to our fundamental matrix. So that would be e to the 5t, 2e to the 5t, that's y1. And then e to the -t, -e to the -t is our y2. That times some vector u of t. So we are assuming our solution is our fundamental matrix times u of t. Then we know that u satisfies our fundamental matrix e to the 5t, 2e to the 5t for the first column, e to the -t, -e to the -t for the second column, times u prime is equal to our f of t. So if we scroll back to the beginning, this 2e to the 3t, and then 5, this is our f of t. So this should be equal to our fundamental matrix times U prime should be equal to 2e to the 3t for the first position and 5 for the second position. Again, this is U satisfies capital Y of t times U prime is equal to F of t. Again, the assumption we were making above was that Y was equal to our fundamental matrix Y of t times some U. So at this point, it's a matter of solving for U prime. So next we need to solve for U prime. You are welcome to solve just as a regular system using row reduction, or you can do Cramer's rule. I'm going to go ahead and apply Cramer's rule in this case. So we'll use Cramer's rule. So we'll first just find our Wronskian, which is the determinant of our fundamental matrix. So e to the 5t, e to the negative t for the first row, 2e to the 5t, negative e to the negative t for the second row. Finding this determinant, we are looking at negative e to the 4t minus 2e to the 4t, otherwise known as negative 3e to the 4t. Then we have our W1 star, in which we replace the first row with our target vector, our f of t. So we will replace that first row with 2e to the, the first column with 2e to the 3t, 5. Leave the second column, e to the negative t, negative e to the negative t, and then take the determinant. So here we are looking at a negative 2 e to the 2t minus 5e to the negative t would be our determinant. For W2 star, we are going to go ahead and leave the first column alone. So that was our e to the 5t, 2e to the 5t. We will replace our second column with our f of t. So replace with 2e to the 3t and 5. Then find the determinant. So we are looking at 5e to the 5t minus 4e to the 8t. Then what we have is U1 prime is W1 star divided by W1. So we are looking at negative 2e to the 2t minus 5e to the negative t divided by negative 3e to the 4t was our W. And so we get U1 prime is 2/3 e to the negative 2t plus 5/3 e to the negative 5t. Our U2 prime, we have W2 star. Oh, sorry, the top one should have been W1 star divided by W. Our U2 prime, we have W2 star divided by W. W2 star was 5e to the 5t minus 4e to the 8t. We divide that by our W, which was negative 3e to the 4t. So we have U2 prime is negative 5/3 e to the t plus 4/3 e to the 4t. Our next step is to solve for U. So we had U1 prime was 2/3 e to the negative 2t plus 5/3 e to the negative 5t. That means that u1 should be equal to a negative 1/3 e to the negative 2t minus 1/3 e to the negative 5t plus c1. Again, taking the integral here. u2 prime was equal to negative 5/3 e to the t plus 4/3 e to the 4t. So we get that u2 should be equal to negative 5/3 e to the t plus 1/3 e to the 4t plus c2. And then D, our next step is simply to find our solution. So find y, which was equal to our y of t times u of t. So we are looking at y is equal to, we have our matrix. Our y of t was e to the 5t, 2 e to the 5t for the first column. And then for our second column, we had e to the negative t and negative e to the negative t. And this multiplies u. So u1 was negative 1/3 e to the negative 2t minus 1/3 e to the negative 5t plus c1. u2, we had negative 5/3 e to the t plus 1/3 e to the 4t plus c2. Note that plus c1 will simply multiply our first column. The plus c2 will multiply our second column, and that is just our homogeneous solution there. So this is, we will have e to the 5t times negative 1/3 e to the negative 2t would be negative 1/3 e to the 3t. E to the 5t times negative 1/3 e to the negative 5t would just be a minus 1/3. And then we will add to that e to the negative t times negative 5/3. Actually, I'm going to write this out. So we have e to the 5t times negative 1/3 e to the negative 2t minus 1/3 e to the negative 5t plus e to the negative t times negative 5/3 e to the t plus 1/3 e to the 4t. That'll be our first row. Again, the C1 and C2 I will add in later. For our second row, we will have a 2e to the 5t times a negative 1/3 e to the negative 2t minus 1/3 e to the negative 5t. Then we'll have plus or minus an e to the negative t times negative 5/3 e to the t plus 1/3 e to the 4t. And then the C1 will multiply e to the 5t to e to the 5t. The first column, our C2 will multiply the second column, e to the negative t, negative e to the negative t. So doing a bit of simplification, our first row, we are looking at a negative 1/3 e to the 3t minus 1/3 minus 5/3 and then plus 1/3 e to the 3t. For our second row, we are looking at a negative 2/3 e to the 3t. Then we have a minus 2/3 Then we have a plus 5/3 and a minus 1/3 e to the 3t. Our general solution, I'm going to rewrite it as plus c1 times 1, 2 times e to the 5t plus c2 times 1, -1 times e to the -t. From here, simplifying our first vector further, we have a -1/3 e to the 3t plus a 1/3 e to the 3t. Assuming I did my arithmetic correctly there, and that just cancels out. And we are left with a -2. Down below, we have a -2/3 e to the 3t minus 1/3 e to the 3t is just a negative e to the 3t. Minus 2/3 plus 5/3 is plus 1. And then this is plus c1 times 1, 2 e to the 5t plus c2 times 1, -1 e to the -t. If we wanted, we could rewrite this as y is equal to, we have the constant vector -2, 1 plus the vector 0, -1 times e to the 3t plus c1 times 1, 2 times e to the 5t plus c2 times 1, -1 times e to the -t. I'm going to quickly check my arithmetic. Assuming my arithmetic is correct, I'm not missing a silly error. This is therefore our general solution. So again, it's not so bad once you have your fundamental set of solutions, at least in the 2x2 case. In the next video, we will go ahead and do a 3x3 example.